We can tell you where the moon will be in 400 years. We can predict an eclipse down to the second and to the particular field in the particular country where the shadow will land. Astronomy is famously the science that gets prediction right. And then there is the sun, which is the nearest star to us by an enormous margin, which we watch continuously with a fleet of spacecraft, and whose behavior next decade we have been almost entirely unable to call. Now, I should say where I stand, because this video is going to end with an opinion. I think the result announced at a conference this month is a genuinely important piece of work, and I also think the way it gets reported is going to miss the thing that makes it good. It is not that somebody has predicted the sun. It is that somebody found a moment when the sun stops hiding the answer. And it matters because the sun's bad days now cost money. Near the peak of the current cycle, a cluster of enormous sunspots produced the strongest geomagnetic storms to reach Earth in more than 20 years. People all across the United Kingdom, who mostly do not get auroras, walked outside and photographed one. And if you asked most people about the solar cycle, they would say that it lasts 11 years, which is the sort of fact that sounds like a timetable. But you know what? 11 is an average, and a fairly rough one at that. Cycles have run short, and cycles have run long. More importantly, the length was never the hard part. The hard part is the height. So here is what we are going to do. First, what a solar cycle actually is and why it has resisted forecasting for so long. Then, the moment this team has found and the number that comes with it. And finally, the big one. What it says about the next cycle and how much of that you should believe. First up, the machine itself. The sun is not solid, so different latitudes rotate at different speeds. That shearing winds the sun's magnetic field up like a rubber band being twisted. And wherever a twisted rope of that field breaks through the surface, you get a sunspot. A sunspot is not a hole. It is a place where the magnetic field has become strong enough to hold the heat down. And the spots do not appear just anywhere. At the beginning of a cycle, they emerge at high latitudes, well away from the equator. As the cycle runs on, each new group tends to appear a little closer to the equator than the last one did. Plot all of that over years, and it makes a shape that solar physicists have been staring at for well over a century. Two wings, spreading out from the middle, drifting slowly inward. They call it the butterfly diagram, and it is one of those rare cases where an enormous amount of patient record keeping produced something genuinely beautiful, more or less by accident. Now, the problem. Everything about how strong a cycle is going to be appears to be decided early and expressed late. By the time you can measure how tall a cycle will get, you are already standing inside it. Forecasters have produced dozens of competing predictions for a single cycle, disagreeing with one another by large factors, and the honest summary of most of them is that they were curve-fitting with a good vocabulary. Which is exactly what makes this result interesting. Professor Sandra Chapman and colleagues at the University of Warwick, presenting at the Royal Astronomical Society's national meeting this month, have identified a specific moment in every cycle when something stops abruptly. Here is the moment. As a cycle ages and its active regions march steadily toward the equator, they eventually cross a line about 15 degrees out. And once the active sunspot regions are inside 15 degrees of the equator, the twisting mechanism that drives the most extreme space weather weakens, and the very worst of it simply switches off. Not the sunspots. Those carry on for a while yet. What ends is the engine behind the most violent events. So the cycle is still visibly running, and the part of it that can actually hurt you has already finished. And the trick is in what you do at that instant. You count the spots. The number of sunspots present at the switch off turns out to be closely related to how high the following cycle will climb. One measurement, taken at a moment you can recognize while it is happening, about the cycle after the one you are in. Which buys you the thing that forecasting has never had here. Roughly 6 to 7 years of warning before the next peak arrives. And it has one real test behind it already. The same approach indicated that the current cycle would be more active than many of the mainstream forecasts expected. That is what happened. The storms I mentioned at the start, the ones that put auroras over Britain, were that prediction being right in public. So what does it say about the next one? Cycle 26 looks moderate. The initial projection puts the sunspot number somewhere around 100 to 120, which would make it comparable to the current cycle, or possibly a little weaker than it. And the team is careful about this in a way I want to underline, because it is the most trustworthy thing in the entire announcement. They say that a more precise forecast is about 2 years away. Not now. 2 years. And honestly, this is where I lose patience with how this sort of thing gets covered. Solar forecasting has a long history of confident numbers that turned out to be quietly wrong, and the field's response has generally been to produce more numbers rather than fewer of them. A prediction that arrives with a stated waiting period is far more useful than a prediction that arrives with a press release, and the waiting period is invariably the first thing edited out. Now, to be fair, one successful call is not a track record. There is a hard ceiling on how much evidence anybody can gather here, because you get one solar cycle roughly every 11 years, and the reliable modern record is not very many cycles deep. Anyone claiming certainty about a method with this few trials behind it is overreaching, and that includes anybody who is enthusiastic about this one. But the reason to care is that the things a solar storm damages have multiplied since the last time we were badly surprised. Power grids, satellites, which get dragged down out of orbit by an atmosphere that swells when the sun heats it. Positioning signals that farming and aviation now quietly assume astronauts. None of that is getting less exposed. And there is something I find genuinely lovely in the shape of this. You cannot experiment on the sun. You cannot run it twice with one variable changed. Every technique for understanding it has to be built out of patient watching, and out of noticing that one particular thing reliably happens before another particular thing. That is not a lesser kind of science. That is most of astronomy, and it is how very nearly everything we know up there was found. So we still cannot predict the sun the way we predict an eclipse, and we very probably never will, because one of those is geometry and the other one is a fluid. But we now have a moment to watch for, and a number to take when it arrives, which is a great deal more than staring at a graph and hoping. Ask again in 2 years.